day 7 slash not. Not in a row. We did a little bit of stuff yesterday too, so. Yeah, you know. We're just here. Anyways. Let's get right into it.
Get started. Okay, here I am at the Jupyter Notebook. I went ahead and said import seaborn as SNS, and then set matplotlib inline. Then I loaded up two datasets. I've loaded up the tips data frame, or dataset, using sns.load_dataset, and then passing in the string tips. And I did a similar thing for the flights dataset, using sns.load_dataset, and then passing in the string flights. The tips dataset we've seen before, here's the head of it, but the flights dataset we haven't, so let's take a quick look at it. The flights dataset primarily just shows the number of passengers that flew in a given month of a given year. Now let's talk about heat maps, which is our primary way of
Let's do that real quick. Let's do tips equal to nice. Okay. Year, month, passengers. Cool.
Here's the head of it, but the flights dataset we haven't, so let's take a quick look at it. The flights dataset primarily just shows the number of passengers that flew in a given month of a given year. Now let's talk about heat maps, which is our primary way of showing some sort of matrix plot. In order for a heat map to work properly, your data should already be in a matrix form. And what I mean by matrix form is so that the index name and the column name match up so that the cell value actually indicates something that is relevant to both of those names. Let me show you what I mean by that. For instance, if I take a look at the tips data frame, right now I have total bill, which is some sort of label or variable, and if I look at one of the values in this cell, it's $16.99. However, the row is not an actual variable. In order to get this into matrix form, I need to have both variables on the columns and the rows. I can do that through many methods, usually through a pivot table or trying to get correlation data. We'll go ahead and do correlation data first. If I call tips.corr, close parentheses, now I have a matrix form of some sort of data here. And what I mean by that is now the column and the index variable names actually indicates a relevancy to both the column and the index name for the cell where they match up. And this is the matrix form you're going to need your data in order to call heat map on it. And then it's actually just as simple as calling sns.heatmap and then your data. Let's go ahead and save tips.core as tc and then pass it into heat map. And here we can see a heat map. All a heat map really does is it colors in those values based on some sort of gradient scale. So if I take a look at my original TC data frame, it's essentially just set these numbers to a gradient on a color scale and then filled it in. And that way, if you have a very large correlation data frame or some other matrix form data, you can easily tell what the numbers are, what the values are relative to each other using a heat map. And that's the main primary use for a matrix plot. Other useful arguments you can pass in here to heat map besides.
I'll do that. So first you have to turn to a heat map. Oh, let's just do flights dot core. Oh, what did I do? Tips. Do tips dot core. Gives us the correlated data.
What the numbers are to heat map.
I don't understand what's going on. I'm just gonna let ChatGPT debug this. I spelled it wrong. I had a feeling that was a problem. Oops. Okay. Oh. have to pass numerically true. I include because the tip's data frame from seaborn contains several non-numeric columns, sex, smoker, date, time. Starting with pandas 2.0 will raise type error if non-numeric data types are present, and you leave numerically false. All right. So it doesn't automatically do it.
Besides just your data is annotation. So you can say ANNOT as an argument equals true, and it will annotate the actual numerical values that belong in each of these cells. So you don't just have to go off of color, but you can also go off of the actual value here. And then you can also specify as CMAP the actual color mapping you want. We'll go over color maps and the options later on in the seaborn lectures, but for instance, just to show you an example, cool warm.
Dude, just join inverted. What the heck? Wait, size. Total bill. Oh, that's nasty. Oh, that's terrible. That's terrible. Yeah, the correlation is 1. Oh, I don't like that. I don't like that at all. I don't like the coloring. Nah.
Is a string that verifies a color map, and here you can begin to see the color map, cool, warm on the same data. Now let's revisit the flights data. I'm going to go ahead and type in flights, and we can see we have all this year, this month, this passengers, and I need to get this into matrix form, meaning I need to somehow get this into, and we can see we have all this year, this month, this passengers, and I need to get this into matrix form, meaning I need to somehow convert one of these variables up here to be the the row names, the actual index. So I want one of these variables, either year, month, or passengers. Let's go ahead and say month, the row names, the actual index. So I want one of these variables, convert one of these variables up here to be the row names, the actual index. So I want one of these variables, either year, month, or passengers. Let's go ahead and say month to be the index. So I'm going to say the index is equal to month. And then I'm going to go ahead and set the columns equal to the year. And then the only thing I have left to do is specify the values, and that's going to go ahead and be the passengers column. Let's go ahead and run this and see what this looks like now. Okay, now I have my data in some sort of matrix form. You can do this with pivot table quite easily, depending if your data lines up correctly. But now you can see I have a bunch of numbers here that correlate well with not just the column variable, but also the index variable.
Okay, wait, let me do this. Flights dot pivot. So my columns. On my rows to be passengers. No, months. So it's called values, columns, index. Oh, this is the index. Okay. Index. Our columns are year. Yeah, no, wait. Our columns. Index columns. Can this work is the question. Or is this this might not work. Yeah. Wait. Yeah, it does work. Okay. Cool.
So I can see here in 1952, for instance, in April, there were 181 passengers. Now what I want to do is use heat map to quickly visualize this data. I'm going to go ahead and set this equal to FP for flights pivot.
Makes sense.
And then just call SNS heat map on FP. And here we can see the heat map for the pivoted tables of flights. And now I can see, based off a color gradient, the data in a lot clearer of a format. So I can easily tell which month of which year had the most flights. And it makes sense that gradually, as the years go further or forward in time, you get more flights. And that makes sense because as time goes on, more people are on airplanes, more flights are occurring.
Don't like that.
Hi, welcome back to this intro to. And you'll see that these data right now have this multi-level index. So that will completely invert your matrix. So to that positive correlation, you're going to choose a palette that starts with red at one end and goes to blue on the other end. This choice might be more appropriate if you want to highlight both small values and large.
There we go. That's what I like. It's a little bit better.
And you can also see, based off the month, that popular month to travel is usually during the summer months, June, July, and August, at least for US data. Now, what you can also do is add in arguments such as CMAP, and let's go ahead and show another example of a CMAP. One that's useful is magma, and now we can also see from dark to light the actual colors here, the variation. Another argument you can pass into heat map, which sometimes people like to use, is line color and line widths. Basically, right now in this heat map, all these cells are touching each other directly, but sometimes you may want some separation. So you can specify line widths to be a little thicker. We'll go ahead and put in 1 there. And you can also specify the line color. I'm going to go ahead and specify it to be white. Now if I run this, I get these lines in between each cell. And sometimes that's a little easier to read. You can make these lines really thick if you want more separation. And you can also change the color of the line. So for instance, if I go back to maybe another CMAP, another one sometimes people use, like we've shown before, is cool warm. And this is what it would look like. Maybe you want something that's not white. You can also choose like black, for instance. So really you have a lot of customization here as far as how you actually want to separate this. Let's go ahead and remove everything and just show the original heat map here. Now let's talk about the second matrix type plot in seaborn, which is the cluster map. And the cluster map is actually going to use hierarchical clustering to produce a clustered version of this heat map. Let me go ahead and show you an example. Here we have the original heat map, but now I'm going to call SNS cluster map on FP. And notice what we have here. We have the data. I need to zoom out to show this completely. But now we have the data and these little hierarchical clusters. And this basically tries to cluster columns and rows together based off their similarity.
Holy crap.
And this essentially shows the years and the months in clusters, and the months here on the y-axis you can see are no longer in order. They go September, June, August, July, October, April. And the reason for that is because they've been clustered to most similar months being put together. And the same thing for years. You can see certain years are now out of order. It goes 1949, 1950, 1953. And this basically clusters the information to try to show columns and rows that are similar to each other. So I can see now that 1959 and 1960 are very similar to each other, and so are August and July. And you can see the different levels of the hierarchy of the clusters based off of these kind of tree diagrams, both on the y-axis and the x-axis. And now you can really begin to infer information from a plot. In order to make this even more clear, what we can do is change the color mapping, so CMAP equal to the string cool warm again. And now we can really see the clusters. So now you can see that there's a cluster between August and July very clearly. And something else you can do is standardize the scale. So right now we're still on passengers from 0 to 600. But if you wanted to normalize this, you can pass in an argument called standard scale and input 1. And this will normalize this from 0 to 1. And now you can really see, based off a normalized scale, the similarities of the clusters based off the coloring. So it looks like these November, January, and February, these kind of early winter months, are much closer to low passengers, and high passenger count is mainly these summer months. Okay, I encourage you to go ahead and explore the documentation for cluster map if this is something you're interested in, but you may want to wait until we actually get to machine learning clustering algorithms so we can better understand what's actually going on with the mathematics behind these methods. For now, you can just think of it as an interesting method to just infer a little more information from a normal heat map. A heat map will display things in the order you put them in. A cluster map will cluster things in an order so that similar groups are close to each other. All right, thanks everyone, and I'll see you at the next lecture.
Pretty cool.
Hello everyone, and welcome to the grids lecture for the seaborn section of the course. In this lecture, we're going to learn how to use seaborn's grids capability to automate subplots.
Goodness, audio just fell. What's going on?
Based off of features in our data. Let's go ahead and jump to the Jupyter Notebook to get started. Okay, here I am at the Jupyter Notebook. I went ahead and said import seaborn as SNS, called matplotlib inline, and then I uploaded the iris dataset.
Just continue.
You can do that just by saying SNS.load_dataset and then passing the string iris. And checking out the head of this iris dataset, this is a pretty famous dataset. It's basically just measurements of a bunch of different flowers or irises. And the last column here on species has 3 distinct types of values. So if I go ahead and say shift enter here and call iris, check out species, you can check out the unique values here. And there's 3 species of flowers possible. It's either Setosa, Versicolor, or Virginica. And the other 4 columns are just features of the flower. powers, such as sepal length or petal width, etc. We're going to see much more of this data set when we talk about machine learning, but for now, let's just go ahead and do a simple pair plot on this data. So pair plot is kind of the automated joint plot for the entire data set. So remember from the distribution plot lectures that we can just pass in the data frame, and it will automatically create this pair plot for us. Now, using Seaborn's pair grid mechanism, we're actually going to be able to customize this sort of pair plot with a lot more control over the actual plot. Let's go ahead and show you how we can do that. I'm going to go ahead and call pair grid instead of pair plot. And pair grid is going to be capital P, AIR, capital G, RID, and then your data frame. So we have pair grid. Pair grid is going to be capital P, AIR, capital G, RID, and then your data frame. So we have pair grid, and this just gives us an empty pair grid. So it takes all the numerical columns and grids them up, essentially kind of making these subplots for us. And pair plot is just a simplified version of pair grid. So pair plot does a lot of this stuff automatically. Pair grid, you have to do a little more, but it gives you a lot more control. Let's go ahead and see how we can use it. The main way is to set this pair grid equal to a variable, and then off of that variable, you can map plot types. So for instance, if I want to go ahead and map maybe a scatter plot, I can say plt.scatter, and this will map a scatter plot to both the upper diagonal, the diagonal itself, and the lower half. Now, if I want to actually specify what I want on the diagonal upper half and lower half, I can specify that command by saying map underscore diag, and this will be the diagonal plot, and we just go ahead and map something to this. So let's go ahead and map a dist plot. To the entire diagonal. And then I'm going to map on the upper plot. We'll go ahead and keep that scatter plot mapped just on the upper, and then on the lower, map underscore lower, I can plot some other plot type, for instance, KDE plot. All right, and notice here, I'm not closing the parentheses off of these plots, I'm just passing in the plot function itself. And it's going to map it based off the data to either the diagonal or upper or lower places in that matrix. So we can go ahead and check that out. This may take a little while to run depending on how fast your computer is, but now we can see we have this sort of pair grid or pair plot, but we have a lot more control over it. Instead of just being scatter plots and histograms, now we can actually choose what plot types we want to map. And that's just the basic idea behind pair grid. Usually we'll just use pair plot since it's simpler and gives us most of the information we want, but if you're ever trying to get a little more customizability out of the seaborn plots, especially pair plot types things, you can use pair grid to do that, and then map the whatever specific plot types you want to the diagonal, upper, or lower. Now let's discuss facet grid. In order to discuss facet grid, I'm going to go ahead and clear this, and I'm going to load the tips dataset by saying tips is equal to SNS load dataset, and then passing the string tips. Check out the head of our dataset. All right, we have our tips dataset that we're familiar with. Let's go ahead and just show you a very simple example of a facet grid by just showing the grid. Similar to pair grid, I'm going to call, let me go ahead and zoom in here a little bit. I'm going to call G is equal to SNS dot facet grid. And then for facet grid, what you do is you pass in the data. So you're going to say data is equal to, or as the first argument, you don't have to say data equals. You can just pass in tips. And then you specify what you want the call to be and what you want the row to be. And this is kind of similar to when we were using subplots with matplotlib, except now instead of saying numbers, you're actually going to pass in column names of your data frame. So for instance, I'm going to say call equals time, and row here is equal to smoker. Let's go ahead and run that and see what that looks like. Okay, now I have an empty grid, and I can begin to actually map plot types to this grid. For instance, I'm going to go ahead and say g.map SNS, let's go ahead and do a dist plot. And let's do it on total bill. So let's go ahead and do that. Let me close that out and run this. Okay, so what's actually going on here? I am mapping a plot type and separating the results based off of, by column and row, certain column names. And here they're labeled for us. So the x-axis represents total bill, but there's 4 separate plots, and they're actually labeled for us. So yes and no on smokers are the rows, and that was specified when I said row equals smoker. And then yes or the actual time of lunch versus dinner is specified by the column. So the left column is lunch, the right column is dinner. The top row is smokers, and the bottom row is non-smokers. And then we have distribution plots for the total bill column. So there's essentially kind of 3 arguments at play here. The rows and columns names for what variables you want to separate by for your facet grid. And then when you're mapping, you're going to want to add in one more argument for what you actually want to map or display. If you're trying to map a plot type that needs more than one argument, so we know this plot only needs one argument, but let's say we try to do a scatter plot by saying plt.scatter. I just said total bill here. I'll get a type error. What I need to do is pass in an additional argument. So I can go ahead and pass that in, and we can say maybe tips versus total bill, and we go ahead and run that. And this actually just needs to be tip. So tip versus total bill. Now we can actually see that we have tip versus total bill, and we've separated both on row and column on smokers and lunch versus dinner. So if you're dealing with a plot type that needs more than one argument, you just add that in as a second argument in the map call. All right, that's actually it for the grid lecture. And the reason for that is because we won't actually be using facet grid that often throughout the course. Seaborn's basic plotting capabilities are actually quite enough for us throughout the course. These sort of grid functions are only here for you if you want to customize your plots even further. And there's a link in the Jupyter Notebook for this lecture with some links to the documentation and more examples of what you can do with facet grid and pair grid. But just keep them in mind when you're looking for a little more customization. Some other plot types, such as regression plots, actually have parameters you can pass that will automatically create a facet grid for you. And we're going to explore that a little more when we talk about regression plots in the next lecture. Okay, thanks everyone. Feel free to post in the Q&A forums if you have any questions on this topic. I'll see you at the next lecture. Column. And now you have rows and times. And this is essentially just doing the grid calls and the facet grid calls that we learned about earlier in the essentially 2 scatter plots and 2. Hello everyone, and welcome to the regression plots lecture for Seaborn. Seaborn has many built-in capabilities for regression plots. However, we won't really discuss regression until the machine learning section of this course. So for now, we'll only cover the lmplot function. lmplot allows you to display linear models with Seaborn. We'll also learn how to size and change the aspect ratio for Seaborn plots. Let's go ahead and jump to the Jupyter Notebook to get started. Alright, here I am at the Jupyter Notebook. I went ahead and imported Seaborn, called matplotlib inline, and I've loaded up the tips dataset that we've been working with. Let's go ahead and show you how to use lmplot to make a very simple linear model plot. You just call SNS lmplot, and then what feature you want on the x-axis versus the y-axis. So let's go ahead and plot total bill, and on the y-axis we'll go ahead and call tip. And our data source will be tips. If we go ahead and run that, we see we basically have a scatter plot with a linear fit on top of it. And you can actually specify hue as well if you want some separation based off a categorical feature. For instance, we can specify hue equal to sex, and now you have essentially 2 scatter plots and 2 linear fits on top of this. And this basically, as far as something to infer out of this plot, is that male and female essentially have the same linear fit as far as total bill versus tip. Something to note here is that you can actually begin to pass in matplotlib style parameters, such as if you wanted to affect the markers or marker types here, you could begin to say something like this. We'll go ahead and say markers is equal to, and since we're dealing with a hue here, we have 2 separate markers we're going to need. So you can pass in a list of markers type. So I can go ahead and say little o for one marker and then lowercase v for another. And these markers, these symbols, come from the matplotlib marker symbols. So we can go ahead and run that, and then we see we have upside down triangles for females and circles for males. Now if that's actually not large enough for you to see, you can go ahead and begin to add in what's known as a scatter underscore KWS parameter. And basically what that means is I can actually pass in matplotlib parameters even more directly into the plt.scatter call. So what Seaborn is doing with this SNSLM plot is it's actually calling matplotlib very much under the hood. And if you want to affect matplotlib directly from Seaborn, what you end up doing, and this is kind of on a case-by-case basis, so you have to reference the documentation as necessary, but if you want to, for this case, affect the scatter plot, you're going to pass in a dictionary. So I can go ahead and say S dictionary and change the size to something like 100, and this will actually affect the size of these markers. I'm going to run that to show you, and now I've made the markers a lot bigger. So this is actually just a call to matplotlib and what's going on underneath the hood of Seaborn. In other words, you're just passing in a dictionary with base matplotlib arguments, and in this case it's S for size of a scatter plot. In general, you probably won't remember this kind of thing off the top of your head, but instead reference the documentation. And you probably won't be customizing to this degree that often with Seaborn. You'll go ahead and customize your data first before doing this sort of action. Let's go ahead and show you a couple more options here in case you don't want to mess around with marker sizing. You can actually use a grid instead of separating by hue. So you can add more by saying sns.lnplot. Let's go ahead and copy and paste the bill, tip, and data. And what we're going to go ahead and do is, after seeing this, instead of specifying something like hue equals sex, which changes the color hue, you can actually start calling factor or grid plots by saying col equals sex for columns. And now you have two separate column plots here, separated by the sex category, so male versus female. So instead of separating it by color, you separate it by columns. And you can continue this sort of logic on rows as well. So if you wanted to add in another variable to see, you can say row is equal to something like the time column. And now you have rows and times. And this is essentially just doing the grid calls and the facet grid calls that we learned about earlier in the grid lecture. But it's a little more automatic because you're just adding call and row to the lm plot call. So it makes it a lot easier. And that way you don't have to deal with facet grid all the time. Now, if for some reason you still want to plot more variables, you can add the hue back in. So you could say hue is equal to, let's say, another column. I'm going to go ahead and say column is day. That way we have Thursday, Friday, Saturday, and Sunday as columns. Let's go ahead and change the hue back to sex. So it's going to give us quite an informative plot, but it's going to be a lot of information here. So as you can see, there's a lot going on here and a lot of information. So we probably just want to go ahead and eliminate row right off the bat and only get one column back. Or one row back, excuse me. And then we have kind of a nice looking plot here, but the problem is that the aspect and size look wrong. So seaborn figures can have their size and aspect ratio adjusted with size and aspect parameters. So you go into your seaborn call, and then you can change the aspect ratio with aspect. So let's go ahead and give it an aspect ratio of 0.6. And this is the ratio between the height and the width of each of these separate grids. And then you can specify size to change the size. Let's go ahead and specify size to be 8. And here we begun to affect the aspect and size ratio of this. And now you're probably wondering, well, how do I change the font size? It's still too small to read, or how do I control the aesthetics even more? What we're going to do is lead this into our style and color lecture, which is coming up next, where we're going to show you how to control these more base features of the plot, such as font size, style, coloring, etc.
Okay.
As far as this lecture is concerned, we're pretty much done. The main thing I want you to get out of this is that in order to call a linear model plot, you just call sns.lmplot, pass in your x, your y column, and set your data, and then you can pass in hue. For these more advanced features, such as setting the marker size or changing the marker type, go ahead and reference the notebook and a link to the documentation in the notebook. All right. If you have any questions, feel free to post the Q&A forum, and I'll be happy to help you out. Thanks, and I'll see you at the next lecture. Hello everyone, and welcome to the Style and Color lecture. We've shown a few times how to control figure aesthetics in Seaborn, but now we're going to go over it in a more formal manner. Let's go ahead and jump to Jupyter Notebook to get started. Alright, here we are at the Jupyter Notebook. I've gone ahead and done the usual import Seaborn, set matplotlib inline, and went ahead and loaded up the tips dataset. Let me go ahead and show you how you can set particular styles. For instance, I can do sns.countplots on, let's say, the sex column and pass in tips as my data. Oops, data equal tips. And here I have my count plot. Seaborn has a set style argument, which allows you to set the style for the rest of your plots. And if we go ahead and do shift tab here to check out set underscore style, you basically pass in a parameter for style. And it's a string. It can be dark grid, dark white, or ticks. I'm going to show you what each of these looks like. Passing in whites, we'll go ahead and create a blank white background for you. If you pass in tick, or ticks, I should say, you basically get these ticks at the edge of the box. Then there's also dark grid, which gives you the original dark grid background. And then there's also what I really like, white grid, which gives you both the clarity of white, but also the grid, so you don't lose that information. You can go ahead and kind of mess around with set style and see which ones you prefer like the best. Now, another thing you can do is remove spines. So right now you can still see, let me go ahead and set this equal to tick so it's very clear what we're doing here. So we have these spines, this top spine and this right spine, as well as the bottom and left-hand spine. If you want to go ahead and remove those, you can just say SNS, the spine, and it'll remove the top spine and the right spine. If you want to continue removing the bottom or left spine, you can actually add those in as parameters. So basically top, right, left, and bottom. By default, top and right are true to be removed, left and bottom are not true to be removed. But you can specify that you do want them removed by saying left is true, and then bottom is true. This will remove basically all 4 spines. So if you're looking for something that's like a very clear, nice looking polished plot, maybe you want to present it without any spines. I personally prefer spines in there, so I'm going to go ahead and remove that and keep those spines. Now let's talk about size and aspect. You can use matplotlib's QLT figure fig size, width, and height to actually change the size of most Seaborn plots, since they are all just basic callbacks to matplotlib. And you can also control the size and aspect ratio of most Seaborn grid plots by passing in the parameters size and aspect. Let me go ahead and show you what I mean by all this. I'm going to go ahead and call the count plots, and note that the set style, even if I delete it, will stay in place until I set a new style. But I'm going to call plt.figure and say fig size is equal to, we'll go ahead and say 12 by 3. And note that this actually overrides, or is a callback, when Seaborn is calling matplotlib. Matplotlib will actually set the figure size for the Seaborn plot. So you can use your matplotlib knowledge as far as figure sizing and aspect ratios here in combination with Seaborn. Now let's go ahead and touch on the topic of scale and context. Seaborn comes with a convenient set underscore context, which allows you to override default parameters and change font scales depending on what you're actually creating the figure for. So let's say you're going to create this figure not for a notebook, but actually for a poster. You can go ahead and say sns.set underscore context, and context will take a couple of parameters. It'll take context, and that's going to be a string, and it also takes a font scale. The context parameters are paper, notebook, talk, or poster. So if I go ahead and just set the context, to poster, notice that I get a much larger figure out, and the font is also larger because it assumes that you're going to be putting this on a poster. And if you're still unsatisfied with the font size, you can go ahead and add that additional argument of font underscore scale to a larger number, maybe 3, so it's 3 times the size of the default. And here you can actually set the context for whatever you want the figure to be in. Usually by default, it's going to be in the context of a notebook. So you can go ahead and say notebook, and that sets the context of your figures. All right, we've gone over just a few of the basics here. The last thing I want to talk about are palettes and colors. We've shown plots before where we actually specify a hue parameter. Let me go ahead and show an example of that. For instance, when we said SNS lim plot, maybe we want to do total bill versus the tip, and then pass in tips as the data set. data equals tips. So we were able to previously specify something like hue is equal to sex, and then we get these colors chosen for us, green and blue. And we've seen earlier that we can actually pass in a palette arguments, and there are certain strings we can put in that essentially give you a color map. And we've seen the similar aspects for things such as the heat maps, when I put in things like magma or cool warm. Now you may be wondering, well, where do I actually find these strings? Well, you can find them by going to matplotlib's color map page. Let me go ahead and show you how to do this with Google. You can go ahead and open a new tab and go to Google and look up matplotlib color map, and it will take you to one of these pages. And what we're looking for is the color map documentation page. And this is usually the first link here. There's color example code. And if we come to this page, now we can see the actual color scale and the gradients, as well as the name or string name you need to pass in for the color map. So if we zoom out here, we can see these 4 color maps. These are the main color maps. But there's also sequential color maps, sequential 2 color maps, another set, diverging color maps, qualitative color maps, miscellaneous, and those are your options as far as the strings you pass in. So for example, let's say I wanted to choose this seismic diverging color map for the hue. Then I just come over here, and instead of cool warm, I pass in seismic. Hopefully I spelled that right. And here we can now see I get this kind of purple and red, which were the colors here at both ends of this diverging color map. And you can go ahead and play around with these color maps. They're a lot of fun to play with in Seaborn to get your plot to look exactly like you want it to. All right. You can go ahead and check out the Juke page, or that notebook, which takes you to the official documentation, which has even more information about really controlling more of your aesthetics in your figure. But the main things to understand and know are that you can look up these palette codes with matplotlib, looking up color maps. You can change the font size with set_context, setting context to either poster or notebook, and then changing the font scale. And then you can use plt.figure with fig size to actually change the size of your figures. All right. I hope you enjoyed this, and I hope you enjoyed Seaborn. Coming up next are some Seaborn exercises for you to do. All right. Thanks, and I'll see you at the next lecture.
Okay.
Hello, everyone, and welcome to the Jupyter Notebook to get started. All right, here I am at the Jupyter Notebook for the Seaborn exercises. It's located under the Seaborn folder, and we're going to be working with a famous Titanic dataset. And you can actually load this directly from Seaborn. So a lot of this code is already laid out for you. These first 4 cells are laid out for you, and you can check out the head of the Titanic data frame and what it looks like. And basically, the exercises are wanting you to recreate the plots shown here below using this Titanic data frame. And there's very few hints, since most of the plots can actually just be done with just 1 or maybe 2 lines of code, and a hint would basically give away the solution. So it's essentially just showing you the plot and asking you to replicate it. Something you should really note here is that in order not to lose this plot image, you shouldn't run any code in the cell directly above it. So for out 41, you shouldn't run any code in 41. What you should do is be running your code right here. So code here in order to not remove this exercise plot image. All right, I want you to replicate this plot right here, this plot, this box plot, and then this swarm plot, and then this plot right here. Pay careful attention to the y-axis for this guy, and replicate this plot, and then finally replicate this plot. Notice how it's 2 separate grids here. All right, that's it for this Seaborn exercise lecture. In the next lecture, we'll actually code out these solutions and explain as we go along. Thanks, everyone, and I'll see you at the next lecture.
All right. This is matplotlib. This is me. This is me. Okay. How do I leave? How do I back out of this? Yeah. Let's just actually go into the thing itself. All right. Have my notes up? Because there's no way in the world I'm going to remember everything. He separated everything. First things first, I'm pretty sure this is categorical. Oof. All right. Should be fun. One second. All right, let's do this. Recreate the plots below using the Titanic data frame. There are very few hints and the plots can be done. Note this and that. Seaborn, my plot lib. Site style, white grid. Titanic equals Titanic. Titanic head. Okay. It's looking familiar. Kaggle. Go replicate the exercise. I like this song. Wait. It's not released. What the heck? Okay, whatever. so large. My goodness. Might have to go cameraless. Alright, let me lock in and go cameras for a second. Ooh.
Hello everyone, and welcome to and then passing the string as possible to either Setosa, Versicolor, or Virginica. From the distribution plot lecture, and making these subplots for you, set this paired group on the diagonal upper half, and then on the grid, now you can see the added seaborn plots set. Right, we have, and then you specify what you want the call to be, and what you can begin to actually run this rows. And that was specified when I said row equals smoker. And then yes, or the actual time plot only needs one argument, this total bill, and we separated both on row and column on smoker. Is false. Okay, so the difference between a histogram here below and this rug plot is that the histogram essentially has bins and it counts how many dashes were in that bin. And then shows it as a number up here. And that means there's between like 10 and, I don't know, 11, there's about people's ages or people. So this is a normal distribution, third argument equal to the data. And we've seen how we can do that using powerful and also very distribution for each of the rug plot points. And that looks these kind of normal distributions, density estimation plots, and the page will look something like this, the distribution line. All right, that's the total bill. What we want to do is build off of this idea of rug plots to explain what this actual KDE plot is on smokers and lunch versus dinner. So if you're dealing with a facet grid that often throughout types such as regression plots, actually have parameters. Everyone, feel free to post in the QA forums if you have any questions on this topic. I'll see you at the next lecture. Get a lot more information and check out our notebook and then changing the form. Now you may be wondering, well, to a larger number is calling that. No, this actually overrides or is a callback when seaborn passing in the parameters size and polished plot. Maybe you want to present it without any default. Top and right are true to be removed. Left and bottom are not true to be removed. But you can specify that you do want them removed by saying left is true and then bottom is true. This will remove basically all four spines. So if you're looking for something that's like a very clear, nice first spines in there, so I'm going to go ahead and remove that. If you want to continue removing, is remove spines. So right now you can still see. Let me go ahead and set the is, and that's going to be this line right here. How do we actually build this line based off of these rug plots? And you can see that it kind of has a relationship to the rug plot count. KDE plots as a box plot, which essentially gives you a whole other files of the data set, passing your data and whatever estimator. And this is just an aggregate, or essentially just a, and then we set in the data for smokers versus non-smoking units. This, and now I have color based, so you immediately understand your data. This is calling them. Hello everyone, and welcome to the Seaborn Exercises Solutions lecture. In this lecture, we're going to go over and we're going to go looking at this plot, seeing that it's so fair is this SNS, and passing the column we want. And if we take a look here at the bottom, this is the fair column. So the distribution of the fair column. I'm going to put this line by itself as a new plot. All right, so this is what you get when you see just SNS this plot. Something we want to do in order to replicate this plot is remove this KDE. So I'm going to go ahead and say KDE is equal false here.
All right, I don't know what happened with that. Cool.
And now we're getting a little closer. Something else to note here is that the color is red, so you can also specify color equals red. Although, as I mentioned in the instructions, you don't have to worry too much about the actual colors. And then there's also less bins here in the fair. So after experimenting with some bins numbers, you can hopefully discover that the bins are around 30 for the plot. And so that's the actual code for the plot. Just a distribution plot. In this case, this plot, Titanic Fair, KD equals false, and then some extra information, red.
I forgot about having been. Oh, shoot. Okay. Oh, well.
And bins. If you weren't
Ooh, okay. I'm gonna finish these up at a later time. It's been good. It's been really informative.